Okay, so let's look at this example so we can write to a file based on a loop. So that means we can enter as many records as we need into the file. And let's review line by line what is written here. So instead of me writing it from scratch this time, I wrote this code and tested it to make sure that it works. And I am going to explain line by line what's going on. So first, we need this pointer so we can use it to point to a new file if it doesn't exist, or to an existing file. Okay? Could I have multiple pointers? Yes. Could I have multiple files opened? And could I be writing to different files at the same time? The answer is yes. You could be also reading from a file and writing to a file if you wanted to do some file processing. However, this example in particular, it will be a runtime program where you enter the data from the keyboard and it will be stored, or the results of that data will be stored in the file itself. So what you need are fields like these that will represent the actual data that will be stored in the file. So what do I need for in this example? I need a first name and a last name and a balance. And that is pretty much what I want to store in the file. So each line will have a first name, last name, balance. Second line, same thing. Third line, etc. So how do we know how many lines do we need in the file? Well, that will be up to us while the program is running to let the program stop at a certain point when we're done. Okay? So before you get started, first thing we need to do, like we've seen in the previous lessons, is you need to set the pointer now to a file. Banking.txt is the actual file that I want to open. If the file doesn't exist, with this syntax, it will create it for you. If it does exist, that's fine. It will open it. So this is a function to open a file. And the second argument here is what mode do you want to open this file in? And notice here I put A for append, which means don't write over what's already in there. Go ahead and create a new line, and that's where you would start recording from. So you will always attach new data to existing data that was already in the file. So you're not altering any data that's in there. So the first thing I'm asking the user here is to enter a first name and a last name. So I am basically populating these two arrays here, right? So they are strings for the first name and last name. And I'm letting the user know if they do not want to pursue this, I am giving them a way out. Okay? Now this Control Z is valid for Windows to let you out, and this is what you want to detect, that was entered through the keyboard. So that means when you get to this if statement right here, it will detect from the standard input if you've typed Control Z you press the Control key and Z together, and that is usually for Windows DOS systems. Control D as in David, is what you might want to write for a Linux-based or Unix-based way to exit the actual processes ahead. So we use that, okay, as an escape. But let's say, so how do you capture it? Well, you have a scanf right here, right after this line, which means it's going to capture whatever you type in on your keyboard. Well, technically, it's supposed to include first name and last name as two strings. Okay? So that is what you were supposed to enter here and here, right? But you could have entered Control Z. This is why I have an if statement here. If that is not detected, the Control Z, go ahead and continue. Ask for the balance and populate the balance variable right here. Okay? So the first time around, you either create your first record while this program is running, right? or you simply decide, hey, you know, I started this application, I really don't need to continue. And if that's the case, then this if statement will be true, which means you will not be entering the balance. Okay? And here you didn't even enter the first name and last name since you hit Control Z at the prompt. Okay? So we reuse the same signal. You still have the signal, Control Z, let's suppose that's what you decided to do. Then this loop here, right? What it will do is going to say, aha, that's what you have. I am not going to execute what's in this loop. Okay? Right? So not, if it's not Control Z, you execute what's in the loop. If it is Control Z, stop. Don't do anything here. So this is a good idea to do a while loop here. So what's going to happen is you go straight to closing the file and you're out. However, let's say you did input a first name and last name. And let's say you did input a balance. Okay? So we know we did not capture the Control Z signal. So the first time around, this while loop is true. So you're going to go in there and guess what's going to happen? You're going to print to the file, fprintf. That's your first line here. Instead of asking for the next data, you need to store that in the file. So notice where the storing to the file happened in the while loop. Why? Because I passed two barriers here before I actually committed data to the file. First, hey, you know, I don't need to enter a balance if I wanted to exit. Well, in that case, you don't need to get into the while loop. Go ahead and exit. However, if you didn't hit Control Z, you definitely enter the first name and last name. You will definitely be asked to enter a balance, which means you intend to store that. And you will definitely get into the while loop since the condition will be true. And what's going to happen is you're going to get in here and say, okay, take first name, take last name, take the balance, and store them in this format right here. So first name with a space, last name, and then hit it /t, which gives you a tab, and then put the balance at 2 decimal points, okay, in the file pointed to by file.ptl. Well, what the heck is that? That's banking.txt. So that's the critical line where it gets stored. Well, while we're in the loop, we're going to repeat the same process that we started outside the loop in terms of requesting for the next record. And again, notice you have a chance to do a Control Z. And if you do a Control Z, which means you intended only to have one record, so while you're in here, this if statement, right, will lead us to, hey, you know, you hit Control Z, so this will not be executed. And the while loop will reevaluate, says, hey, wait a minute, you hit Control Z, so we'll not execute the block within the loop, and you get out onto basically close the file and get out. However, if you didn't hit Control Z, then you will be entering. That's because you entered first name and last name. Well, in that case, this is true, right? And what's going to happen is you're going to enter a balance, and you're going to evaluate again. You're going to go back to the top of the loop. Well, guess what? That record that you have here will be stored in this top line here. And then you'll be asked to do this again. So let's see how this works. So let me compile and run this. And by the way, I have this file stored somewhere, the actual product, and it's called banking. Let's go ahead and delete it, just show you that we could start this from scratch. So yes, I'm going to delete it. Okay. Now we're going to go over here and compile and run. Okay. Fantastic. So notice it's going to say, do you want to do a Control Z or do you want to enter data? Well, let's do a Control Z quickly. So Control Z, and I'm going to hit enter. Notice press any key to end the program, which is the last line in the in main. It definitely closed the file, so fclose was executed. Okay, so I'm going to hit the space bar. Let's look again into the files, and I have banking because I've opened it, but it's going to be blank. There's nothing in it. Okay, so let's close that. And let's go back. Now, what I could have done is included or opened this file to improve this in this if statement, because that is the time when you committed to actually store something into the file. So let's take this line here. So as you can see, you can always find better improvements. So let me cut this. And the fact that I'm in here, it's because I want to open the file and store data in it. So might as well put it right here. Now let's see if this improves the situation where if the first time ever I come around and I hit Control-Z, I don't want a blank file. So this should solve that problem. So let me compile this for a second. Good. And what I'm going to do is go to that file and delete it again. There you go. Now let's go ahead and run it and do Control-Z right away. So we're going to run this. And let's say we changed our mind. So we're running this program. We decided to change our mind. Control-Z. Okay. Now let's look at the file. And it's not there, which is perfect. So the only time the file will be created if you didn't hit Control-Z the first time and you actually went ahead and put a first name and last name, right? So no Control-Z was captured. So let's go ahead and create that scenario. So let's go ahead and run. And instead of Control-Z, I'm going to enter a first name and last name. So Henry Ford. And because of that, the if statement is true now, and it's going to take us into the enter a balance, which means at this stage, it should have opened a file. So I'm going to leave it the way it is, just show you. I'm going to go into the directory and notice the file is there and it's got 0 kilobytes. I haven't committed anything to that file, so it's got no bytes in it. That is because I'm not inside the while loop. Remember, the actual commitment of the data will happen in the while loop. And so let's go ahead and continue running this program. So I'm going to put $25.78. Okay. And now notice it's asking me to enter the first and last name, else exit Control-Z. So I'm inside the loop. But by now, data got committed. Well, let's see if that's true. We should see 1 kilobyte. Well, it didn't until I closed the file. Okay. So well, it should have. Let me see why it didn't do that. Let's open it. It didn't commit the data. Well, let's see. Let's continue on and see when does it do that. And let me do a Control-Z. Right, so let's do that. And the program. And let's see if it actually did that. Yes, it did. So it waited until the process was over, right? And then it committed that data. So let's see here. Here he is. So I was just verifying here. So it probably needed to get out of here before it did that. Let's go ahead and enter a couple more records. So let's compile, well, let's run. We don't need to compile and run. And let's put Bob Marley in there. And let's put 34.89. Okay. Now let's see. Well, obviously at this stage, that data is not committed. Let's go ahead and do another one. Janet Jackson. There you go. Very good singer. And enter a balance, 78.34. Now watch this. I'm going to hit enter. So I am inside the loop, but I want to verify what's going on with the file. Okay. And notice nothing really happened. Well, let's see what happens once we get out of the file. Or we get out of the application itself. So Control-Z. Okay, let's see if these two names got appended. So I'm going to go over here. And sure enough, Bob Marley, Janet Jackson. Okay, so we just need to be patient. There's probably a file buffer that's not running in parallel, but it's running in series with what we're doing. Okay, I could be wrong in my assumption, but that's what we're observing at this stage. But no matter what, this application is accomplishing what we need: first name, last name, with a tab. And notice all the balances are lined up. Okay, you don't necessarily need a tab. Sometimes it's a good idea to keep it consistent in terms of the tokenization or the delineation of these fields. So if you're going to use a tab across, or just a space, and so on. Okay. Because in the future, you want to make sure that these files could be searched, let's say through a script like a Unix or Linux script that looks at a delineator like a slash, a space, a dash, and keep it consistent across the line. Here, I put a space and a /t just so it looks good in the file. But that's not typically how you would want to store into a file. Just keep the spaces consistent between each piece of a record within a line. Okay, so if you're going to do a /t, do a /t between Henry and Ford, /t between Ford and the amount. Okay, or just basically spaces or slashes. And again, it all depends later on if you have a script that requires that delineator to realize, okay, that's how the words are tokenized within that record. Keep that in mind in terms of your file structure. Okay. My example here is for illustration purposes. So it's not the best way to store a file or to store to a file, but it does work. And again, let me repeat what I did here. As you can see, I had and I even formatted the data in there. Okay, which means you need to know the structure of this file if you're going to read it. However, if you put spaces, pretty much that's pretty straightforward in terms of the structure of the file when you're reading it back into an application. So keep that in mind as well.